Now this is admittedly a little different. We have 6 discrete points. So what we're going to do is for each point consider where it emanates from on both the x-axis and the y-axis. Well, this has an x value of -3 and a y value of -3. This point has an x value of -2 and a y value of -2. This point has an x value of -1 and a y value of -1. This point has an x value of 2 and a y value of -3. This point has an x value of 4 and a y value of an x value of 3 and a y value of -4, and this point here has an x value of 4 and a y value of -6. So we want to state this in terms of domain and range. Well, our domain would appear to be only the numbers -3, -2, -1, 2, 3, and 4. So we can state that different ways. We can say x is an element of the reals such that x equals -3, -2, -1, 2, 3, and 4. Or we can say x such that x equals -3, -2, -1, 2, 3, and 4, and x is an element of the reals. But think about it, this is pretty redundant. We're defining the values for x. These numbers are real, so there's no point in saying x must be a real number. We're stating that by giving the numbers individually. So, in fact, the best and most concise way of writing this domain would simply be the domain is the set of the numbers -3, -2, -1, 2, 3, and 4. Similarly, we're going to look at the range now, and the range is going to be the numbers -6, -4, -3, -2, and -1. Notice I don't start with -1 and go down to -6. I start with -6 and go up to -1. It's not wrong, but it's a little bit nicer by convention to state the lesser numbers first, or the lesser interval first. So you can probably imagine now that our range can be stated in this redundant fashion or this redundant fashion, but it's perhaps best of all to say that the range is simply the set of these numbers, -6, -4, -3, -2, -1, and we put the least number first and proceeded to get greater numbers after that.